Okay, so let's learn about Porphyria. So for learning about Porphyria, first of all thing which you need to know is heme synthesis. So I hope you already know heme synthesis. If not, I will also provide heme synthesis step line by line and problem associated with it. So first of all, porphyria is something in which there is deficiency of some of the enzymes present in between the intermediates, so that if that enzyme is not present, the precursors product become accumulated in the cell, and that creates problem. So let's see. So first thing, you need to know that succinyl coenzyme A and glycine combine to form delta amino levulinic acid. So if there is enzyme ALA synthase, so if this enzyme is not present, then we are going to face X-linked X-linked. So there will be X-linked sideroblastic anemia. Alright, and then after the formation of delta amino levulinic acid, 2 delta amino levulinic acid combines and form porphobilinogen, and the enzyme here is ALA dehydratase. So if this enzyme is deficient, there will be ALA dehydratase deficiency porphyria. Alright, so then after the formation of porphobilinogen, there is formation of hydroxymethylbilane, and 4 porphobilinogen combines to form hydroxymethylbilane. So hydroxymethylbilane is also known as uroporphyrinogen 1. Alright, so the enzyme used will be hydroxymethylbilane synthase, because hydroxymethylbilane is forming, or uroporphyrinogen 1 synthase, because it is uroporphyrinogen, and it is the same enzyme, only the name is different. And there is one more name, that is porphobilinogen deaminase, because this formed by the deamination. Alright, so it is a deamination reaction. So all this name is for the same enzyme. Alright, so if there is deficiency of this enzyme, then what will happen? Then we will get acute intermittent porphyria. Alright, so now let's see one thing. So this step is very crucial. So above this, in all the condition, there will be presence of abdominal pain and neurological problems. Alright, so there won't be photosensitivity. But after this, in all of the porphyria, there will be the photosensitivity. Alright, so now let's move to the next step. So after hydroxymethylbilane, we get uroporphyrinogen 3. Alright, so uroporphyrinogen 3 is formed by uroporphyrinogen 3 co-synthase. Alright, and then after Okay, so right here there is a, if this enzyme UPG3 co-synthase is not present or it's partially absent, then then the porphyria developed is congenital erythropoietic porphyria. Alright, so congenital erythropoietic porphyria will be there. Alright, now after the formation of UPG, uroporphyrin engine 3, we get to the next step, that is coproporphyrinogen 3. Alright, and the enzyme used is UPG decarboxylase. Alright, and I think yes. Okay, so decarboxylase means removal of carbon dioxide. So we don't have to remember any porphyria from uroporphyrinogen to coproporphyrinogen. Alright, now after coproporphyrinogen we use CpG oxidase. Alright, and the things form is protoporphyrinogen 9 or 3, it's your choice, you can write anything. Alright, so if this CpG oxidase is deficient, then we will going to suffer from so in this one UPG decarboxylase, there is also presence of one porphyria, I'm sorry, that is, and it is very important porphyria, and that is protoporphyria, and that is Porphyria cutanea tarda, and this is the most common porphyria. And I am saying that this is not present, I'm so sorry. So this one is Porphyria cutanea tarda, and it is very much important. Alright, so now let's move ahead. So protoporphyrin 9, after formation of protoporphyrin 9, we get protoporphyrin, and at last we get heme. Alright, so from protoporphyrin 9 we get protoporphyrin by PPG oxidase. Alright, and at last from protoporphyrin we get heme from using ferrochelatase, or we can also use heme synthase. It is the name of same enzyme, sorry, heme synthase. Alright, so now let's see what happens if these enzymes are not there. So if there is a deficiency of ferrochelatase, we get protoporphyria. Alright, and if there is deficiency of PPG oxidase, we get variegate porphyria. Alright, and if CpG oxidase is deficiency, then we get one of the hereditary coproporphyria, and that is called hereditary coproporphyria. Alright, so let's revise once again. So let's see. Succinyl coenzyme A from Krebs cycle and glycine from the dietary products come, and it is a simple amino acid, and these two combines to form delta aminolevulinic acid. Alright, so if the enzyme ALA synthase is absent, we get X-linked sideroblastic anemia. Alright, now after this, if after By combination of 2 delta amino linoleic acid, we get porphobilinogen. What do we get? Porphobilinogen. And the enzyme responsible for it is ALA dehydratase. What is that name of the enzyme? ALA dehydratase. So if ALA dehydratase is deficient, then we are going to be suffer from ALA dehydratase deficiency porphyria. All right. So in this porphyria, there is nothing different. You need to name the enzyme and then after deficiency porphyria. All right. Now, porphobilinogen combines to form hydroxymethylbilin. What is it? Hydroxymethylbilin. And the enzyme is hydroxymethylbilin synthase or UPG1 synthase or PBG decarboxylase, deaminase. So if any of these enzyme is given and said it is deficient, then we need to say acute intermittent porphyria. All right. Then after, if the UPG1 3 enzyme co-synthase is deficient, then we are going to uh, suffer from congenital erythropoietic porphyria. All right. And if there is deficiency of UPG decarboxylase, and you need to remember this because this is the most common one. All right. What is this? UPG decarboxylase. All right. If this enzyme is deficient, we are going to suffer from Porphyria cutanea tarda, and it is the most common one porphyria. All right. And if the CpG oxidase enzyme is deficient, all right, what is happening? If CpG oxidase enzyme is deficient, then we are going to suffer from hereditary coproporphyria. What are we going to suffer from? Hereditary coproporphyria. All right. And if PPG oxidase is deficient, then we are going to suffer from variegate porphyria. All right. And if there is deficiency of ferrosiltase or heme synthase, then we are going to suffer from protoporphyria. So this is all, and I want to make you remember this. This is acute intermittent porphyria and congenital erythropoietic porphyria and porphyria cutanea. This you can remember from mnemonic ACP, and these are very much important. All right, acute intermittent porphyria and congenital erythropoietic porphyria and porphyria cutanea. So, and enzyme is also very much easy. So this is due to deficiency of UBG. It is uroporphyrinogen. Yes, UPG1 synthase deficiency, and second one, this one is due to UPG3 co-synthase deficiency, and this one is due to UPG decarboxylase deficiency. So all are due to the same, almost the name of the enzymes are also same. All right. So these are ACP, and then after there is hereditary, variegate, and protoporphyria. These are not that much important, but protoporphyria is sometime asked. All right. So keep in mind. And then after, so that's all. This is all about the porphyrias. I think I could make you understand. And one main thing I've already told you that all the porphyria above this are only with the symptoms of neurological problems and abdominal pain, and all after these porphyria are with photosensitivity with neurological problems. All right. And then after, one more thing, how, yes, one question used to be asked that how photosensitivity acts. So see, for example, there is deficiency of UPG3 co-synthase. All right. So we will be accumulated with uroporphyrinogen 1. All right. So this will form protoporphyrin. All right. And now in the presence of UV light. All right. And this protoporphyrin will generate free radicals like oxygen. All right. And this free radical will act on lysosome. in cell, and this lysosome will cause the cell to burst and hemolysis, and this is the cause of photosensitivity. So this lysosome cell burst, so we get photosensitivity. So at last we get photosensitivity. All right, and the range of UV rays which affects most is 400 nanometer. All right, so this is how we get photosensitivity. And one more thing, hydroxy. All right, so congenital erythropoietic porphyria is, in this there is uh, less severe form of photosensitivity than this uh, Porphyria cutinata. Why? Because this has two enzymes, this one also and this one also. So these both are just combining and forming the problem. So in that CEP, there is less severe form. So that's all from my side. Thank you.